Hey, so throw your name on here. It is currently second hour. We are looking at factoring out the greatest common factor of polynomials today. So I have this entire unit been telling you guys we've already added, subtracted, and multiplied. 5.5 through 5.9, so the last 5 sections of the entire unit are all factoring. Factoring is the opposite of multiplication. We can think of it as unmultiplying. It's not really dividing though, because you don't yet know what you're dividing by. So I think of it as unmultiplying. The GCF, or greatest common factor, is the largest monomial that every single term in a polynomial can be divided by. So greatest means biggest. Common means it has to be in common between all of the terms of a polynomial. And then factor means they all have to be divisible by it. We're looking for the biggest thing we can divide everything by. Your GCF can have 2 parts. It may have one, it may have the other, it may have both. It can have a coefficient. So that's just going to be the biggest regular number that you can divide everything by. It can also have a variable and an exponent, and that's how many x's that you can take from every single term. Once we figure out what the GCF is, we will divide the coefficients, and we are going to subtract the exponents. So we will divide the coefficients, we will subtract the exponents. Factoring out the greatest common factor is the exact opposite of multiplying in 5.3. If you remember back to 5.3, we multiplied our coefficients and we added our exponents. So now we're doing the opposite of both of those things. We're dividing our coefficients, we're subtracting our exponents. Put it away. Okay, so we've got 4 examples here. The first 2 have both parts, the last 2 just have one part or the other. So the first problem we have is 21x to the 6th minus 12x to the 5th plus 15x to the 3rd. So we always want to deal with the coefficients first. So we want to look at 21, 12, and 15. We want to find the biggest number that we can divide all of those by. What can we divide 21, 12, and 15 all by? 3. So we can divide them all by 3. Cannot divide them by anything bigger, so that is going to be the coefficient part of my GCF, is a 3. Then I need to figure out how many x's I can take. I've got x to the 6th here, I've got x to the 5th here, I've got x to the 3rd here. You're always going to be able to take however many x's the one with the least has. And since our polynomials are always going to be in standard form, that's always going to be at the end. So this is going to be 3x to the 3rd for our GCF. So then what we're going to do is we're going to take that 3x to the 3rd, we're going to write it down in front of a set of parentheses. And then we're going to divide everything by 3x to the 3rd. So each term we are dividing the coefficients, we are subtracting the exponents. So 21 divided by 3 is 7. 6 minus 3 is 3. So I've got 7x to the 3rd power. Negative 12 divided by 3 is negative 4. Subtracting my exponents, 5 minus 3 is 2. And then 15 divided by 3 is 5. 3 minus 3 is none. There are no x's left on that last term. We can go ahead and just close our parentheses. Okay. Any questions on that guy? Okay, we have one more that's super similar, and then once I get done with all these, help me remember to show you how to check them. We've got 6x to the 5th minus 18x squared plus 6x. What can I divide 6, 18, and 6 all by? A 6. So I can divide them all by 6. You also might be like, well, I could divide them all by 2. I could divide them all by 3. You are correct that you could divide them all by 2. You are correct that you could divide them all by 3. But we want to divide by 6 because we want the greatest common factor. We don't just want any old common factor. We want the greatest one. Then we want to look at how many x's our term with the least x's has. This last term here, there's an imaginary 1. So I can pull out 6x or 6x to the first because that last term has an x just by itself. Okay, so we'll throw that in front of our parentheses. 6x to the first. Okay, 6 divided by 6 is 1. And then 5 minus 1 is 4. So I've got 6, or I've got 1x to the 4th in there. Negative 18 divided by 6 is negative 3. For my x's, 2 minus 1 is 1. And then we can kind of look at this whole term together. What is 6x to the first divided by 6x to the first? What? What is anything divided by itself? 1. So the 6 divided by 6 is going to be 1. And the x to the first, so 1 minus 1 is none. You still need a placeholder 1 there, though. Okay, now is a great time, now that we've seen this one with that placeholder 1, to show you guys how you can check these real quick. So to check these, you could just distribute it back, just like we did in 5.3, and it should always match your original answer. So 6 times 1 is 6, 1 plus 4 is 5. 6 times negative 3 is negative 18, 1 plus 1 is 2. 6 times 1 is 6, 1 plus none is 1. So you could just distribute back in every single term, and you should end up exactly back where you started. Okay, any questions right now? Hey, we've got 2 more then. The last 2 only have 1 part. So out of 16 and 24, what can we divide 16 and 24 both by? 8. Awesome. Okay, how many x's does this 24 have that it can give me? None. Does that 24 have any x's? No. So all we can divide out of this one is an 8. So 16x cubed divided by 8 is just going to be 2x cubed. And then 24 divided by 8 is going to be 3. Okay, next one. What can we divide 7 and 5 both by? 1. So 7 and 5 are both prime numbers. We can't divide either of them by anything other than 1 in themselves. There's no use in dividing them by 1, because dividing them by 1 doesn't change anything. With that x to the 4th and x squared, though, how many x's can we pull out? 2. So since that last one has an x squared, we can go ahead and pull out just an x squared. So we've just got an x squared that we're going to pull out here. So 7 divided by 1 is still going to be 7. X to the 4th, take away 2 of them. We still have 2 left. I forgot to close my parentheses here. And then 5x squared, divide out the x squared. All we have left is 5. Okay, I want to point out a couple patterns, and then I will give you guys your assignments. What do you notice about this and this, this and this, and this and this. They're all the same. If my polynomial is in standard form, which we're going to give you all your polynomials in standard form, other places you might want to check to make sure that they're not trying to trick you. The last term in standard form is going to have the least number of x's. That's how many you're going to be able to pull out. And that's why this one has none and we can't pull out any. Okay? What do you guys notice about, a different highlighter? This, 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 and this. What do all of those have in common? They don't have any x's. They're all just a constant. Why don't they have any x's? Right. We are always going to take however many the last guy has, and so then the last guy's never going to have any left, okay? So you always take however many the last guy has, and then he doesn't have any left. Right. Yeah, well, he can deal with it. Tough love, Mr. Last term in a polynomial. Okay, I'm going to stop this video.